Hello students, welcome to the channel. In this basics explained video, we'll look at dot plots, bar graphs and histograms. So let's begin. So this question here is from the May 2021 US SAT. Each of the three data sets represented by the three dot plots has 15 values. The medians of data sets A, B and C are small a, small b and small c. What is the relationship between them? So what exactly is a dot plot? It's a way of representing data. For example, here you have 15 values. 2 occurs once, 3 occurs twice, 4 occurs 4 times, 5 occurs 4 times, 6 occurs 3 times, and 7 occurs once, right? So if we were to write this as a list, it would be 2, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6, 6, and 7. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values, right? So this is how the data is represented on a dot plot. You have the data sets here and you have the frequencies represented as dots. Now, for a set of 15 values, the median would be the 8th value, because 15 is an odd number. So n plus 1 by 2, which is 16 by 2. So the 8th value. So what is the 8th value for data set A? It is 1, 2, 3, 4, 5, 6, 7, 8. So that's 5. What is the 8th value for data set B? 1, 2, 3, 4, 5, 6, 7, 8. So this is also 5. And the 8th value for data set C is 1, 2, 3, 4, 5, 6, 7, 8. So this is also 5. So we find that the three data sets have the same median. A is equal to B is equal to C, option D. Let's do another problem. This is from the April 2021 US School Day SAT. The dot plots show the distribution of heights in inches of members from 4 basketball teams. Of the data set summarized by the dot plots, which has the smallest standard deviation? So here again, if I wanted to list out the numbers, I could say data set A is 66, 72, 72, 74, 74, 74, 76, and 78, right? And similarly, I could write out a list of all other data sets. Now, standard deviation is deviation from the mean, right? Which is to say deviation from the central value. And you can see that if you compare the 4 data sets, then the data set that's most concentrated around a value is data set D, right? Because there are 1, 2, 3, 4, 5, 6. There are 6 times that 72 appears, and 68 and 76 appear just once. So in fact, the mean here would be 72, right? Because this is 4 units left and this is 4 units right. And then 72 itself appears 6 times. So most of the data is concentrated around the mean. It's the mean itself. So deviation from the mean would be the lowest in this data set because the data is right here around the mean. If you look at other data sets, they are more spread out, right? Data set A is spread out from 66 to 78. Data set C is also spread out with some values around 66, 70, 74, and 78. And data set B has just one value each for 64, 66, 68, and so on. So the level of spread is the lowest in data set D, and so standard deviation is the lowest. So that was the dot plot. Now, what is a bar graph? A bar graph is basically representing exact values for a particular category, right? For example, in this question from the April test, the bar graph shows the number of discovered near-Earth asteroids by classification as of April 2017 Of the near Earth asteroids, how many more are classified as medium, large, or very large than are classified as very small or small? So you have exact numbers given to you. The number of medium near Earth asteroids is 4055, large is 3808, and very large is 876. So medium, large, and very large together is 4055, 3808, and 876. So that's 8 and 6, 14, and 5, 19, carry 1. 5 and 1, 6 and 7, 13, carry 1. 8 and 8, 16 and 1, 17, carry 1, 8. Right? So these total 8739. What about very small and small? That's 2911 and 4406. So that's 6 and 1, 7, 1 and 0, 1, 9 and 4, 13, 7, right? 7317. So how many more of the first category than the second? That would be 8739 minus 7317, 2241. So 1422 is the difference between the two groups asked in the question. Another problem. This is from the May 2021 international test. The bar graph shows the frequency of each data value in a certain data set. What is the minimum data value in the data set? So if you were to write this as a list, you can see that 10 appears 3 times, 11 appears 4 times, and 13 appears 2 times. So this is 10, 10, 10, 11, 11, 11, 11, and 13 and 13. But we don't have to do that because they are asking the minimum value of the data, which you can clearly see is going to be 10, right? So 10 is the minimum value. Let's now look at histograms. So histograms are different from bar graphs in the sense that they give you a range, right? So they don't give you specific values, but a range. So for example, there are two data sets here, and I know that there are two values between 0 and 10, 5 values between 10 and 20, 3 values between 20 and 30, and so on, right? So unlike a bar graph, which gives you a particular value and its frequency, this gives you a range in which the frequency lies. So the two histograms show the distribution of data set A and data set B respectively. Data set B is the result of removing the outlier from data set A. So outlier is the value which is far away from the other values in the data set. So that has been removed in data set B. Which of the following statements about the means of data set A and data set B is true? So we are supposed to compare the means. Now, if you'll think about it, the two data sets are identical except for this one value between 60 and 70. So let's say this is 65, just for the sake of understanding. So you can see that the mean of the first data set will be pulled to the right by this extremely large value, right? Because when you sum the values of data set A, then 65 is much greater than all the other values, right? Because you have two values between 0 and 10, 5 values between 10 and 20, and so on. So this is much greater than the values, and it will pull the mean to the right. So the mean of data set A would be greater than the mean of data set B. You can, of course, calculate the exact mean by taking some values, but you don't need to, because just the fact that this 65 is to the right of the data set would mean that the mean is also pulled to the right. So B. Another question. The histogram shows the distribution of book prices in dollars for the 27 books for sale at a store. So again, because this is a histogram, we have a range. So there are 9 books priced between $0 and $5, 11 books priced between $5 and $10, 6 books priced between $10 and $15, and 1 book priced between $35 and $40. The first bar represents books with prices of less than 5. The second bar represents books with prices of at least 5 but less than 10, and so on. In which interval will the median price of books for sale be included when the book that costs at least $35 but less than $40 is sold? So this book has been sold and we are now left with 26 books, right? So they are asking the median price for these 26 books, right? Now for 26 books, the median will be the average of the 13th and 14th values, because when n is even, the number of terms is even, the median is the average of the n by 2 and n by 2 plus 1 value. So what will be the 13th value? There are 9 values between 0 and 5 and 11 values between 5 and 10. So both 13th and 14th values will lie in the 5 to 10 range, right? So the average of those two will also lie in the 5 to 10 range. So therefore, the median for the remaining 26 books will be at least 5 but less than 10. Option B. So in this video, we looked at the basics of dot plots, bar graphs, and histograms, and solved some questions from recent SAT tests. Hope this exercise was useful. There are a number of other videos in the Basics Explained series in which I tackle concepts that you are likely to see on SAT and ACT Math. I'll link to this in the description box, so do check it out. I'll see you guys in a new video soon. Take care. Bye-bye.